Hello everyone. In this video, we will be discussing about what is a cluster and its major components and the types of Databricks cluster and the cluster architecture. So before going to this cluster, let me tell you what is compute basically. First of all, we need to understand the compute term. So compute is the processing infrastructure that executes our workloads in Databricks, right? Whenever we execute any notebook or a SQL query or PySpark application, compute provides the CPU, memory, and virtual machines required to process the data. Think of compute as the overall processing power provided by Databricks. One important thing to remember is cluster is one type of a compute. Okay, cluster is a one type of a compute. And now let's go. Like, what is a cluster? A cluster is a group of virtual machines. You can think of it like a virtual machine. What group of virtual machine is considered to be as a cluster. Together, all these virtual machines process large volumes of data. Instead of executing data in a single machine, Databricks distributes that work across multiple machines, making processing much faster and scalable. A simple definition, if you want, cluster is a collection of VMs that work together to execute a Apache Spark applications. And first of all, why do we need actually clusters? Imagine like you have 1 TB of data. You have 1 TB of data. If only one computer process it, if only one computer process it, it may take several hours, right? Instead of what Databricks will do, it will create multiple VMs. Multiple VMs, you can think of it like this worker nodes. Multiple VMs will be there. Each machine process a portion of the data simultaneously. This parallel processing significantly reduces the execution time. That is why we use the clusters in the Databricks. So now let's go with the major components of a cluster. Every Databricks cluster mainly consists of 3 components. One is driver node, worker node, and executors. So coming to the driver node, it is the brain of the cluster. Main responsibilities like receives user code, creates any Spark session, or converts the code into Spark jobs, split a job into multiple stages, or it will split the stages into multiple tasks, assign tasks to worker nodes, collect results, display outputs. Remember, one important thing is only one driver node exists in a cluster. Now coming to worker nodes, it performs the actual computation. It is the one which actually compute your data. So main responsibilities is like receives task from driver node, read the data, process the data, perform some transformation, return results to the driver node. A cluster can have one or many worker nodes. Depending on your workload, it can be assigned. And coming to the executors, it runs inside the every worker node. Whatever I'm saying, all are listed in this architecture. We can simply go through it once this is done. The main responsibilities for the executor is it executes the Spark task, process data partitions, cache data into memory, return results to the driver. Think of it like this: driver node is a manager node, worker node is a employee, and executor is like an actual person doing the assigned work. Okay. Now types of Databricks cluster. We have 2 types of cluster. One is all purpose and second one is job cluster. These are the main types of a Databricks clusters you can think of. So the all purpose cluster is used for development related tasks and the notebook execution, or for any data exploration, analytics, and testing and debugging. And the job cluster is used for mainly production ETL jobs, schedule jobs, automated workflows. And this all purpose cluster, if you think, these are created manually and multiple users can use it, suitable for interactive working environment, can remain running until stopped or auto terminated. For this job cluster, created automatically when a job starts. There is no manual creation of this job cluster. It will automatically start and terminate once the job is completed. It is a cost efficient for production. Now, same thing what I have explained, the Spark cluster architecture, we have this driver node. It is a head node you can consider of. The Spark context is the starting stage of your Apache Spark application. The cluster manager is responsible for managing cluster nodes, assigning compute, all these things. And it contains the driver node it will contain the application logic and controls entire your Spark application. And the Spark context is like an entry point, as I mentioned. It is an entry point for the Apache Spark application, mainly responsible for connecting the applications to the cluster, create Spark jobs, or communicate with the cluster manager. The Spark context will be helpful for communicating with the cluster manager. Without Spark context, the application cannot communicate with the cluster. In modern Spark, like Spark session is the main entry. Okay, instead of the Spark context, in modern terms, like we have the latest version Spark, the Spark context can be replaced by Spark session. And this cluster manager is mainly responsible for resource allocation, mainly responsible for allocating CPU and memory, and starts executors, manage worker nodes, monitors cluster resources. In Databricks, this resource management is handled by the Databricks platform. Now coming to these worker nodes, these machines perform the actual computation. Each worker contains one or more executors, and the executors executes the task received from the driver node. They also cache frequently used data in memory, improving performance. Now coming to the task, a task is the smallest unit of work in executing in the Spark application. Each executor process multiple tasks. We can say task 1, task 2. Multiple tasks will be present based on your partitions. And the term cache. Cache stores the frequently used data in a memory. Benefits like faster execution, reduced disk rates, improves Spark performance. So I will also explain the difference between the cache and the persistence. That is one of the most important question we can get it in many of the interviews. So I will cover that important topic in upcoming session. So the end-to-end flow, I will give you one example. For example, the user writes a PySpark notebook. Okay, the driver program, this is the head node, it receives that code, notebook code. Once that notebook code is received, Spark session or Spark context internally connects to the cluster. The driver converts the code into one or more Spark jobs. Each job is divided into stages. Each stage is divided into multiple tasks. The cluster manager allocates these resources and executors to execute that code on the multiple worker nodes. Executor execute the task in parallel. If data is reused, executors cache it in memory for faster future access. Executors return the results to the driver node. The driver combines the results and displays the output in the notebook. This is the entire flow it will follow whenever any Spark job or any query is getting executed in the Spark application, Apache Spark. So thank you for watching this session. If you have any questions, please put it in the comment section. Please follow and subscribe to our channel. Thank you.